let me move on to the next presentation. So the next presentation is coming from ATMOCE. We have Alec Curry, who is a product manager at ATMOCE. He is going to talk the multiple installation applications for solar module inverters.
Yes, thank you very much, Shravan. So ATMOCE is the name of the brand. Yes, I'm the product manager for the DACH region, so the German-speaking regions. Let me just share my screen. Yeah, that should be working. And I was just going to go over so it's very much linked to all of the previous topics we've had presented so far. And what I'll be looking at is what exactly is a module inverter, not to re-educate anyone who's already highly educated here, why use them, and then the actual applications and benefits and the ATMOCE AC architecture. So simply put, a module inverter is always at panel level inversion. So the smallest technical system we could see is one inverter per panel. And we'll go into why that's a benefit here. So this is where I spend most of the presentation actually. And here you can see in the one phase and three phase systems, we have in every row one inverter per panel. And on the right hand side, we've got why that is a benefit. So for every panel, you have maximum power point tracking. And that really leads into what we've seen earlier in these presentations as to why that might be interesting. So basically, regardless what type of panel or where the panel is, that panel is producing at its maximum power point, regardless of any external influence. Scalability and flexibility. The smallest system we could provide would simply be just one inverter, one panel. So for balcony systems, that's a great. For ATMOCE, we probably have priced a little too high for balcony systems, and we require an electrician to install, but that's a different story. And for maximum system size, it's then basically only regulation and wiring that you need to look at. Have you got the correct regulation to go over 100 or 130 kilowatt? And if yes, then you can do that with these systems. So number three is really the main playing point for microinverters, module inverters. We prefer to say module inverters because DC voltage is really where the risk of fire is coming in, and especially here in Europe, but I think probably anywhere where you've got parties that would like to lobby against photovoltaics. This DC voltage and the risk of fire is your main weakness. Panels only get more powerful, and with that, more and more DC voltage. Therefore, the string inverters need to be bigger to handle all of that. But it means you also have high DC voltage cables running through a building or through a field, regardless of the installation type. And with an AC system with module inverters, you have AC coming at panel level. So every micro or module inverter, every panel is connected to an AC bus, and that AC is coming directly into the building or wherever it may be. And AC, as I think we all know, all appreciate, is much easier to protect against with residual current devices and with other protective devices. But yes, at 200 or 230, 240 volts of AC, the risks there are much lower than 600 or 700 volts DC. Number four is then interesting for the end owner, end user. The fact is, depending on the panel, is how much power you'll actually need from your module inverter. Is that 400 watts? Is that 600 watts? This is low power. I think we can all agree in terms of the big picture. And low power is much easier to keep going for a long time. It's like walking a long distance or sprinting it. Yeah, so each of our module inverters has no moving components. Goes also for other manufacturers, not just ATMOCE. But yeah, technically we can give easily a 25-year warranty and guarantee on these devices, knowing full well that they can go much longer. Number 5 is then interesting as the PV world gets more digitalized. We want to optimize our production, and for that we need data at panel level, not array level, and control as well. So in Europe, we're already seeing some problems caused by overproduction, and here we can control production at the panel level, and still get the most out of our PV system. And that goes then nicely with point number 6, is that we have all this data. The micro itself, or the module inverter itself, can make its own decisions should we go out of these parameters and notice that something is wrong. As we see in all these use cases, if between the inverter and the panel, we should have a DC cable damaged by wildlife or however, then the inverter could shut down and flag up an error as soon as that happens. And then there's no risk of fire, no risk of damage, and the rest of the system can even, in most cases, keep producing. And we know exactly where the problem is because we have that information on a cloud service, in an app, however you want to view it. The no single point of failure is, as I just mentioned, if there should be anything wrong with a single inverter or a single panel, or maybe even a string, it can shut down, and the rest of the system can keep producing. If you have systems relying on backup, or batteries that need charging, or just maybe an installer can't come out to fix as soon as possible, then this will play a role in end customer satisfaction. And then so these being low power, they can start up off the power of one panel in the case that they need to be off grid completely. Is there a blackout and we're disconnected from the grid? Then the inverters can start up on their own accord as required, or shut down in that case. So these are some of the main points of our products that would go for similar products in the class. A maximum of 60 volt DC is what we have a limit for our devices currently. And under that, under 60 volts, you're very unlikely to get any sort of DC arc. Which means you also don't need the arc detecting devices. So installation is much simpler and safer. As I mentioned, the 25-year warranty for installation is incredibly easy. You can probably hold a box of 20 or 40 in your arms, and then you've got almost the weight of a modern string inverter. Rapid shutdown, important for many markets as fire safety. And then efficiency is something that we're seeing year by year increasing and getting towards string inverter levels. So 97.4 is definitely an impressive number. And IP67, class 2 isolation, so we don't have to really worry about AC earth leakage. And we can install in any circumstances where where you're expecting flooding or salty seaside locations. Here's just another overview of how the system works on the roof. We've got DC voltage for maybe 1 meter between the panel and the microinverter, and then 230 volts coming straight out. And then the typical system, if you have 10 panels or 9 panels in a string, that's already more than enough to do damage to the installer, or to start a fire if something should happen with this wiring. Here we see a typical residential system where we have shading from the chimney, from the extra roof here. And in these cases, with such strong shading, we would get, regardless of the bypass diodes, we still get a decreased performance for the entire string in a string system. But with module inverters, we don't get that. Panel A does what panel A does, and panel B does what it does. Okay. And here's then two. Yeah, so we have the previous slide. We could have what is our potential daily production. So 60% would be obviously the minimum here, right next to the windows. This panel would have been left out in many installations. But with module inverters, the installer can still install that panel, and that panel will still bring a decent amount in its 25-year life. And if we can convince installers to install more panels, then that's good for the installer, good for the industry, good for everyone involved. On the right-hand side, we have a table of what are to be marketed as identical panels, but the maximum power point, as we can see there, the voltage and the ampage, it differs quite some amount. Yeah, so no two panels are identical, just as no two people are perfectly identical. And the best thing about teams of people and teams of module inverters is that we get the strengths of and the differences from each one. So regardless, the bigger the system, the more difference you're going to have between your panels. So yeah, the benefits of having them all working at their perfect point is then maximized. And then here, just these are graphs from our cloud of typical patterns you might see throughout the day, but one need not negatively affect another. Okay, so applications and benefits. Many of these have already been discussed today. These are our typical residential solutions. So we have yeah, all over Europe, you have small houses with various different exposures, not just east-west, but many different angles. Then the house might also want a facade or a fence to go with it, or a carport. And then you've got all these different panels, all in different angles, all producing different times of day, their maximum. So let's get the most out of each of those. And on a residential level, with use of a battery, you do want to get the most out of your system. So for in-roof systems, tiles and these somewhat bigger tiles, yeah, then you can't avoid that each panel is in a different direction and has, yeah, for chimneys here, we got the snow protection there. There's all sorts of things casting shade at different times of day that negatively affect one panel, two panels, but need not affect the entire system. So this is a big theme that's been going today. On the left-hand side is actually the town hall in the city where I live, and with yeah, building an integrated PV, you either plan your PV system knowing that there will be shading and that's going to infect the entire string, entire system. But we can't take this fire risk, so we need to reduce the DC voltages on the building already. And in most cases, as in our system, is indeed plug and play and is very easy for the architect to plan with the help of an electrician. Yeah, so each of these panels is producing at different times of day. Maybe some never produce anywhere near their maximum, but that shouldn't have a negative effect on another panel somewhere else in the system. If an inverter or a panel should be defective, then we can simply, for example, every 5 years, the company who's looking after the system can just, he'll know exactly where the modules are because of us having array, because of us having the module level data. And he can fix however many are defective every 10 years, every 5 years, without having to go through and search the entire system for the defect. With this typical string system, this would be impossible. And even with an optimizer system, you have high levels of DC, which is then upping the fire risk. Slowly in Europe, we're getting some more infrastructure like this. We have bike paths covered by PV. We have bike paths where the floor is the road is PV. And then, especially in the picture above, we can expect at some point one of these panels is likely to break, and we can't rip up the entire road to find out which one it is. But with our system, that one is isolated and no single point of failure, so can continue working. And obviously, these are in public spaces, so safety against fire, safety against high DC voltages should be of utmost importance. And then with bifacial, yeah, module inverters are getting much more powerful. Our largest is 600 watts, as panels are reaching that amount of output power. Agri-PV has already been mentioned quite sometimes today. Yeah, so again, minimal DC voltage ensures livestock safety. Yes, where we have cows, we have mice, we can have rats, we can have anything that could be chewing through cables. And then you've got, 600 volts, 700 volts of DC in this metal system, which could lead to a fire or to livestock damage. An important business way to look at this is that insurance companies are also not keen. Insurance companies and banks are not keen to invest in these projects if there is a risk of fire or DC electrocution. So with our system, especially in France, this is already clear that some insurance companies are only accepting module level inversion for the products they finance. And then, as you can see, we have internationally regulations that for typical systems would be difficult to fulfill, and for our architecture is really no problem. With rapid shutdown for the USA, and then minimum DC voltages, minimal DC cable length in other parts of Europe. And then just briefly over our system, we also have an AC coupled battery, as batteries are becoming even more and more important as feeding into the grid is becoming less attractive, especially in Europe. So self-consumption is becoming more and more important, and this is why an AC battery can be installed with any typical system or with our system. And where you install a battery, you also want the maximum production, especially with BIPV. This too, you don't want to just throw away potential power. And then you get all the smart home, smart system, load control is then also easily done through our architecture. So that is my presentation through. Hopefully I'm not too far over.
No, I think it's a really interesting, Alec. But one question: if many times in your presentation you mentioned it's the DC voltage. So, but when you convert it into AC, but at some point you also have AC cables, which probably are also, when you connect them, are also not so friendly. So is it going to be different?
So our inverters are double insulated, and we have galvanic separation between AC and DC. So it's impossible to have DC on the AC side of the cable. And then on the other, our cables are double insulated. As I said, the inverters, you can't get electric shock directly from the casing. And I think it's still easier for electricians who are installing for buildings to install AC cables. It's what they know. For example, when I did my electrician training back in 2007, 2008, PV was a black magic. We said if you need to ever do that, you'll get taught that separately. We don't know anything about that yet. So so yeah, it's for electricians, AC is what they know. They know how to install it safely. We have over a century of expertise installing AC, and we have better protection, simply better protection for AC systems with the RCD.
Okay, and so obviously, so that means your inverter per module might also increase the cost, right? So if that's not really a secret, would you like to indicate a little bit about how much expensive it could be for a typical household?
Well, I joined a technical branch so that I wouldn't have to ever talk about prices, but it seems like I can't avoid that. But we at ATMOCE at least are on par with an optimized system, if not cheaper in many cases. I think until at least ATMOCE got onto the market, it was always too much of a factor to consider. But yeah, as the advantages of module inversion have kind of been seen on a technical level, it can only get cheaper the more we sell. So yeah, it's as price I can't say exactly, but we are at least on par with an optimized system. And I think especially for building integrated PV, you would want at least optimized because you have so much shading and different dirt and different directions. So yeah, the cost has been a large factor up till now, but ATMOCE is doing everything it can to breach that gap and become competitive with the string inverters.
Oh, okay.
Yeah.
Okay. Thanks a lot for this nice insights into the inverters.
Thank you very much. Have a nice weekend.
Bye. Wish you the same. And yeah, so please, if there are any questions in the chat window, please try to answer them. Then